When you go to the y equals button on your calculator, if there's anything in there already, you can clear it out. So just arrow up and down and push the clear button to clear out anything that's in there. The other thing I want you to check is always look up at the top of your screen. Do you see how plot 1 on my screen is darker, like it's been selected? That means that there's a plot on. And when there's a stat plot on these calculators, it can mess with your graphs. So you need to turn those off. If they ever are on, you simply arrow up until that plot is blinking and then push enter, and that will turn the plot off. So you want all 3 of those plots at the top of the screen to be not highlighted. Okay? In the y1, you're going to enter our first function. To enter x, you use the button that looks like x, comma, t, comma, weird circle thingy, which actually is theta, comma, n. It is diagonal from the second button or right next to the green alpha button. So that's the button that you use to put x in. So here's the activity we're going to do. First, enter the parent function f of x equals x squared into y1 equals. Now you don't have to put f of x equals, that's the y1 equals. We're just going to enter in x squared. So push the x button. And then the square button is diagonal up from the 7. So x squared. The first time you grab a calculator, especially if you're using one of my calculators and not your own, you don't know how this calculator was used previously, so the window may be completely screwed up on the graph. To make the window a standard -10 to 10, -10 to 10, push the zoom button and then number 6. Zoom 6. Zoom button is the middle button at the top of the calculator. And then you push number 6, which says Z standard. Zoom standard means it zooms your window into a standard -10 to 10 on the x-axis, -10 to 10 on the y-axis. All right. We need to sketch that graph. We are going to compare everything else to this graph today. So notice it is a nice smooth U shape. I'm going to try to actually get this sketched nicely. The place where that U shape changes direction is called the vertex. That's probably too wide, isn't it? I'm really struggling with actually getting this drawn. So as I get this sketched, I would like you to try step 2. We are going to leave that original function in y1 equals, and next enter g of x equals parentheses x minus 3 squared into y2 equals. Once you get that entered, you don't need to do zoom 6 again. Now you can just push your graph button, which is the button on the top right of your screen. So take a moment, graph that, and then we're going to sketch that and talk about how it's different and how it's the same. This graph moved right 3. Do you suppose there's a connection between moving right 3 and the fact that there was -3 inside the parentheses? What do you think would happen if it had been +3 instead of -3? You are correct. If we had put in parentheses x plus 3 squared, it would have moved to the left. So notice that side-to-side movement is backwards. Minus actually means left, plus means right. All right. On your own, I would like you to try step 3. Delete out y2 equals and replace it with the h function. Sketch it, talk about how it's different, and then delete that out and put in the j function and then talk about how that's different. So do the rest of that on your own. All right, the h function. 2 times x squared. What did you notice about that graph compared to the original graph? It was thinner or more narrow. Are you noticing that what you're seeing is very similar to when we did absolute value. That every function that we're going to see this year, these same transformations apply to all of them. So a number in front is going to either stretch or shrink the graph. If that number is bigger than 1, it's like it vertically pulls on the graph, which makes it get narrower. If that had been a 1/2 instead of a 2, it would push on the graph vertically, which would smush it out and make it wider. And f of x equals, or is that j of x? J of x equals x squared plus 1. What happened there? Up 1. Is it wider than the original x squared? Do they look the same? Let's find out. X squared plus 1. Oh, I know why it looked wider. Because it's moved up 1, you're not seeing as much of the graph. It takes a minute for it to graph. There we go. It looks a little bit wider, but it is just shifted up 1. There's no number in front, so it's not going to be wider or narrower. It's just shifted up 1. A horizontal translation. You already saw this. A horizontal translation is adding or subtracting inside the parentheses. And up at the top of the page, I would suggest you write this formula. So inside the parentheses, that minus h is the horizontal translation. And as we saw from the activity, it's backwards. So plus will actually move to the left, and minus will move the parabola to the right. Now, if I consider that minus h to be inside the parentheses, does it make sense to say that the plus k is outside of the parentheses? Horizontal transformations happen inside the parentheses. Vertical transformations happen outside of the parentheses. So this is adding or subtracting outside of the parentheses. And here it's absolutely normal. So plus means up and minus means down. Okay, next we're going to fill out the vertical reflection. And over here, I'm going to graph. You don't have to do this on yours, but I'm going to do it. Negative x squared. I want you to see what happens when we put a negative in front of the x squared. Some of you are already guessing what's going to happen. So as it draws it, what happens if there's a negative in front? It flips it over the x-axis. If you reflect over the x-axis or in the x-axis, they're going to use the phrase over the x-axis or in the x-axis. Those two phrases mean the same thing. It means a vertical reflection over the x-axis. You put a negative in front outside of the parentheses. Here's an example. Y equals negative x squared, or y equals negative something like that. If there's a negative in front outside of the parentheses, or if there aren't any parentheses, that is a vertical reflection. Okay, now we'll talk about horizontal reflections for a minute. Take this original function. If I was to reflect it over the y-axis, do you see how that parabola is symmetrical? So if I reflect it over the y-axis, it's going to reflect the two pieces onto themselves. So a horizontal reflection really doesn't do a whole lot, but here's how it would work. It would be a negative inside the parentheses. Here's why it doesn't appear to do anything. What is 2 squared? 4. What is negative 2 squared? 4. Because we're squaring, a negative inside the parentheses really doesn't do anything because we're still going to square it and get a positive number. Stretches and shrinks. We are going to use the vertical stretches and shrinks a lot more. It's the A value that you see in that formula we wrote at the top of the page. If A is larger than 1, it is going to be a stretch. For example, y equals 2 times x squared. That's a stretch, and it's going to make it more narrow. Because we're vertically pulling on that parabola, which makes it taller. It stretches it. That ends up making it narrower. If your number is between 0 and 1, like the fraction 1/2, or 1/4, or 2/3, that is going to be a vertical shrink, and it's going to make the graph wider. Because if we push on it vertically, it's going to squish it and make it look fatter. Okay. A horizontal stretch and shrink is really messed up and weird, and I will never put it on a test. A vertical stretch or shrink, you multiply the reciprocal inside the parentheses. It has to be backwards, messed up, screwed up somehow because it's a horizontal transformation, and all horizontal transformations are kind of screwy. So if we want to do a horizontal stretch by a factor of 2, it would actually be 1/2 x in the parentheses squared. You would multiply by the reciprocal inside the parentheses. Vertical stretches and shrinks, you multiply by the number outside the parentheses, period. There's nothing weird about it. You just stick that number in front of the parentheses and call it good.